We're going to talk about the least squares regression line. So in the Flamingo book, this is section 3.2. In the blue book, it's 3.2. No, sort of. It's probably, in the Flamingo book, it's definitely 3.2. In the blue book, it's 3.2 and 3.3. So the other day we really talked about correlation, and that correlation makes no distinction between the response variables and the explanatory variables. So today we're going to talk about regression lines. So a regression line, I love regression lines, is a line that describes how a response variable y changes as an x. I'm sorry. I do not know why I made this so tiny. Explanatory variable. I don't know why I said x. Explanatory variable x changes. So a regression line describes basically the response variable y changes as an explanatory variable changes. We often use a regression line to predict the value of y. You guys, a regression line is just a line, but we are going to use y equals a plus bx. That's the equation that we use, and that's our stat calc 8. Okay, so one of the things that the AP exam loves is to ask you how to interpret the slope in context of the problem. They love that. They love to give you a multiple choice question about that. They love to give you a free response question about that. So, given a regression equation, can you interpret the slope and y-intercept in context of a problem? Context of a problem. If it is not in context of a problem, you will lose a point. Okay? And how do you do that? It's just the slope, the amount of which y changes. You know this drill. When x increases by 1 unit. So you guys, the x will always increase by 1 unit. So as the amount of study time goes up by 4 hours, the GPA increases by 1, right? 1 grade point average, 1 GPA, if that was one of them. Or as GPA increases, or as study time increases by 1 hour, GPA increases by 4. That would be great, right? Wouldn't that be great? Okay. The number A is the y-intercept. You guys, I'm going to tell you that not always is the y-intercept going to make sense in context of the problem. Okay? You guys are going to have to know that. They will ask you, hey, what happens when it's 0? I'm sure you guys talked a little bit about this in Algebra 2 and Algebra 1. So it's the same thing. It's just you just have to imagine now that we're looking at a lot of real-world problems, and we're going to be discussing a lot of these things. Okay? Now, can you explain what is meant by extrapolation? Okay. So, when you do these things, we're going to predict, okay? And there's 2 types of predictions that we do. You're going to be given a set of data, and within the set of data, you're either going to be asked to predict with inside or outside. So like if our data goes from 0 to 10, and I say, hey, what do you think would happen at 12? That is what we would call extrapolation. If I asked you, hey, what could we predict at 8? And 8 is not one of those values, but our data, our x values went from 0 to 10, and I asked you what would happen at 8. That's interpolation. Extrapolation isn't as reliable, because you are predicting outside the range of the data. Remember, you guys, when you go to graph this line or this regression line, you are looking at the data that they gave you. We are making predictions on that line within, for that given data. Yes, we're trying to predict outside, but If we predict outside, it's not always going to be reliable because it's outside of what we have. So, extrapolation. Can you explain what is meant by extrapolation? It's the use of a regression line. The use of a regression line for prediction outside the range of values of the explanatory variable x used to obtain the line. Such predictions, I do not know why these lines are so small, are not accurate. Sometimes if you're close enough to the data, like if you have a point that's close enough to the data, like let's say 10 is our last x value, right? And I ask you to predict 11. Sometimes 11 will be fairly, like it's still extrapolation, but it might be more reliable than if I asked you to do 15. Because 15's so far out of that range. So make sure that you're paying attention to what they're asking you to do. You guys, the one thing they love for you to do is to interpret that slope and to talk about extrapolation. They want to know, hey, they want you to predict stuff, but they also want to know if you know that extrapolation is not reliable. Okay. Let's see, because we're going to talk about, okay, I want to go to 14. Okay. Can you explain why the regression line is called the least squares regression line? So yeah, we can, because we're about to do it. So we're on number 13. The least squares regression line, the least squares regression line, the Lsrl. Yes, I messed up. That should not surprise anyone. It's 6th period. You can abbreviate this on the test. Like on the AP test, on my test, you can write the Lsrl. You do not have to write out least squares regression line. This is one of the abbreviations that they allow. Of the x on the y is a line that makes the sum of the squared vertical distances of the data points. Did you like that long breath? I wanted to give some air. From the line as small as possible. You guys, we have a point. We're trying to make it as small as possible, okay? They're not going to ask you too much about this, but we look more at a least squares regression line than we do at a regression line. The other thing you need to know is that a regression line very much takes in the account what the explanatory variable is and what the response variable is. Whereas correlation makes no distinction, the least squares regression line, it does care. Okay, so now I need to put some stuff around here. So you guys, people laugh at all of this all the time, but this should be y hat. So you should put a hat over the y. Yes, it is called y hat. It is the prediction value, okay? So y hat equals a plus bx can be found by giving the correlation, the standard deviation of the explanatory variable, the standard deviation of the response variable, and x bar, y bar. So the other day when we found correlation by itself, and we found the x bar, y bar, the least squares regression line is always going to pass. The least squares regression line is always going to pass through x bar, y bar, always. Is part of the reason that we use it for correlation. Given a set, we put information into our calculator the other day into list 1, list 2, but now, and I told you how to do a stat calc 8, list 1, list 2. I did that on the video too. That is how you can find your least squares regression line and your R. So again, it's just stat calc number 8, list. If you have the fancy smancy calculator, it will already have like list one, and then it will, not list one, but it will already have which list, and you just put in which list you want to do it. Okay, I'm not talking about residuals yet today. I just want to talk about least squares regression line. Okay, and we are going to find the least squares regression line by hand because guess what? This is something, you know how correlation, I said they will never make you find correlation by hand. They will give you the information to find the slope in the least squares regression line just with information. The good news is you get your formula sheet. So can you guys take out your formula sheet? I'm going to show you on your formula sheet how the formula for least squares regression line, okay? So right here, this is right here, are the equations you need for least squares regression. So you'll see R. Do you like how I did R better? So you can see this is your correlation. This right here, this is how you find slope. Use slope, and then you find A. So this is to find A, to find the y-intercept. And just so we're clear, you are writing on your formula sheet how to find things. You are not going to get to use this formula sheet on the actual test. Because you've just written on it on how to find things, and I need you to know how to find them without your little notes. Because remember, the day of the AP test, you will not have your own formula sheet. You will have your formula sheet. It will just be one that is provided by the College Board. Okay, so that last sentence that we wrote, right? It says that you can find all of this if you know your R, you know your standard deviations, you know your X bar and your Y bar. That is all you need, because from that you can find slope and you can find your y-intercept, and then you can write your least squares regression, and that is your least squares regression line right here. It's just nice for the R, just so you remember that each observation is being standardized. So you will have to find slope for me, you will have to find the y-intercept, and you will have to write it in the least squares regression line for me. Those are all things that you will have to do. So what do you need to know? The least squares regression line definitely cares which is the explanatory and which is the response. Notice that there's no standardization. The only time you standardize something is for correlation. You also need to know that each least squares regression line goes through X bar, Y bar. And you use StatCalc 8 to find it. And that this right here is actually called Y hat, and it's your prediction value. So remember, your least square, you're using your least squares regression line to help you predict. The information they give you is what you observe. You use your least squares regression line to predict. Those are the difference, okay? So once you get that least squares regression line, you can predict what's going to happen. Okay.